So this one is the last synthesis problem of the chapter 20 notes, and we have to make this product from alcohols of 5 carbons or less. Why alcohols all the time? Turns out that alcohols are commercially available usually, and they're relatively inexpensive because they are acquired from nature pretty readily. So we need to use alcohols 5 carbons or less. What about our product? Our product has a total of 1, 2, 3, 4, 5, 6, 7, 8 carbons. Just looking at it, we probably don't want to construct a new ring, so we could use this ring component as one of our alcohols. So 1, 2, 3, 4, 5 carbons, and then 6, 7, and 8. And really, I'm just numbering kind of randomly. All we need to do is make sure that the units that we're numbering over here are in the reagents along the pathway to get us these products. So this would break down really well into a 5 carbon unit and a 3 carbon unit. So how are we going to do this? Well, we need to somehow make one of these the electrophile, one of them the nucleophile. We have to make one of them negative, one of them positive. Same thing that I just said there, just 2 different ways. So we are in chapter 20, the organometallic chapter. How do we do that usually? With organometallic reagents. So if this carbon here is the negative component, and you could do it either way. So I'm going to do it one way, but theoretically either side of this broken down piece could be the positive side or the negative side. So if we break this down to make this big thing the organolithiate, we're going to have an organolithiate, or actually this time we did a lithiate last time, we're going to do a Grignard this time, just to show that they are interchangeable. So we have our Grignard there. What are we adding our Grignard to? We're adding our Grignard, and we'll write the solvent too, diethyl ether. We're adding our Grignard to a carbonyl, and it has to be the carbonyl in position 6. So we're going to add that to this carbonyl here. Just to number all of our carbons, this is carbon 1, 2, 3, 4, 5. And this is 6, 7, and 8. So we have all of our carbons. And once we add these 2 together, we're going to have an alkoxide again, the O-. We have to protonate that. So to protonate that, we're going to use H3O+ for our acid quench step. So again, take a minute to think about this. Write out the product of these 2 steps, and then restart the video. Okay, you've done that now. You've predicted that the product of these 2 steps is that molecule there. So now, the last step here is we have to, or the last steps, is we have to somehow remove this alcohol, and we're actually getting to the alkane up there. So those are some reactions that we haven't encountered in a while. We haven't thought about them in a while. But how did we remove an alcohol? We dehydrated. We dehydrated with sulfuric acid and heat usually. So when we have sulfuric acid and heat, that protonated the alcohol, made it into a really good leaving group, and then we had an elimination occur. So when we treat this molecule, the products of 1 and 2, with this reagent here, that's going to eliminate, and it's going to form this alkene. This is a tetra-substituted alkene. It has 4 different things off of that alkene. It's a really stable alkene. We could have formed the other alkene. That would have been a minor product because the more substituted alkene is the more stable alkene. So that's what happens when we treat this with sulfuric acid and heat. But now we have an alkene. We don't want an alkene. We want to go all the way to the alkane. So how do we do that? Well, that's a reduction, right? We're adding H2. We're adding a hydrogen there and a hydrogen there. We're adding H2 to that molecule. That means that it's a reduction. And the way to reduce alkenes is with hydrogen and a metal catalyst, a catalytic hydrogenation. That is H2 with palladium on carbon is the most common way to do that. Palladium on carbon. So that reduces that alkene to the alkane. We've gone from this and this to the product. Now we have to say, well, how do we get to that from alcohols 5 carbons or less? Well, the alcohol equivalent of this molecule would be this alcohol here. We're just going to reduce it, or to oxidize it with pyridinium chlorochromate, that's PCC, with DCM. That gets us to our ketone. What about the Grignard reagent over here? It's MgBr, so we'll draw that one right here. So how did we get to that? Well, we treat an alkyl bromide with magnesium and an inert solvent like diethyl ether. Well, how did we get to an alkyl bromide? We had to take an alcohol and treat that with a brominating reagent like PBr3. Again, we could have used HBr here instead. PBr3 is probably just a little bit faster. Okay, so that's how we synthesize this. That's how we synthesize this big molecule from alcohols 5 carbons or less. And what I want to take a minute to do now is just reflect on this example and the last example, and also the example on page 15 at the top that we did in class. Essentially, what are we doing? We're taking alcohols, we are making them electrophiles. How are we doing that? We're oxidizing them to a ketone or an aldehyde. Those are electrophilic functional groups. So we're doing that with half the molecule, then we take the other half of the molecule and make it into a strong carbon nucleophile. How did we do that? Well, we took the alcohol, we made it into an alkyl halide, and then we made a Grignard or an organolithiate. So essentially that's kind of what we always do in these synthesis questions is we take alcohols, we make them either into electrophiles or nucleophiles, then we react them with each other. Once they react with each other, we always have some type of alcohol product. That was right here. And in this case, the alcohol product needed to be dehydrated and then reduced. In the last example, the second example on page 15, the alcohol product needed to be oxidized to get to the desired product. So those are kind of always the steps. We make the things into positives and negatives, we react those two together, and then we modify the products with other reactions that we know. So hopefully this is starting to kind of be kind of straightforward because it needs to get there so that you can excel in this course. And I really want you guys to get there, so let me know if there are any questions.